Engineering, IIT BHU. Our distinguished guest has completed his PhD in the area of additive manufacturing, 3D printing from IIT Delhi. He has more than 7 years of teaching and research experience. He has 11 international journal papers and 4 international conference papers to his credit. He has 2 Indian patents granted to his credit. I consider it my great honor to welcome Dr. Pawan Sharma to enlighten us on the topic investment opportunities in the field of reverse engineering. Sir. Welcome, sir. The stage is all yours.
So, thank you for giving me the opportunity to talk on a very latest topic in the field of engineering, which is basically reverse engineering. We are, all things, a lot of things in forward engineering path, but now there is a tremendous change in the scenario in the engineering field where we are talking about rapid product development and reverse engineering and integration of reverse engineering with 3D printing plays a significant role in that rapid product development. So my lecture will focus on the investment opportunities in this area. So basically reverse engineering, from the name itself, it might be clear to all of you that reverse engineering means that the product is existing in front of us and then we go for redesigning of that product we are trying to develop a documentation for that product. It's actually not limited to that only. This is what all the people all around globe which do not have the knowledge of reverse engineering, they think about reverse engineering is limited to only the product is obsolete or it does not exist the parts, so we can reverse engineering. No, it is beyond that. We can also develop a novel product also using reverse engineering, and I will showcase those things also. So basically why we require reverse engineering? For competitive benchmarking, for a product in the market, we can provide a low-cost product in the competitive world. For smart manufacturing, which is a need of an hour, IoT-based, artificial intelligence-based manufacturing, we can use reverse engineering to achieve this smart manufacturing. Then, as all of us know that reverse engineering is for obsolete part development, design development. If the part does not exist, so we can develop the design of that part if it is in front of us. Then documentation, this is very important. I'll come to it later on also when I'll discuss the prospects of reverse engineering, design documentation. Then it can also be used for characterization of the samples. It can also be used for inspection as well as quality control also. In fact, it is in automotive industries, people are using it largely for these activities. For product improvement, in the existing design, we can make improvement using reverse engineering. For animation and virtual reality, we can use the reverse engineering designs to create the simulated environment for our engineering purposes. Like for example, in coal fields, we can develop a simulated environment of a whole coal field using reverse engineering, and we can identify the bottlenecks that we might face in the real situation. Then process simulation, like in case of biomedical industries, for a surgery, which is a very complicated task. So we can use reverse engineering to in fact simulate the complete surgery before even we can perform it on a real patient. So this is where reverse engineering can help us. So now what is the current scenario? Current scenario is the conventional product development cycle that we follow. It initiates with conceptual design. It is a serial type of thing, that design, then prototyping, then manufacturing, and then if some failure occurs, we again go to this conceptual designing. So this is no longer exists now. People are moving forward, way ahead. That is rapid product development. That means all the things that exist in serial production cycle, they have to be done simultaneously or parallelly. And this is known as rapid product development. So we can do designing and simultaneously we can also think of manufacturing like using additive manufacturing technologies or 3D printers. So we can see what are the problems and we can identify those problems. So it results in time saving. Basically the path of product cycle using reverse engineering. So as I've told you, this is the conventional way that we are doing, till date we are doing it. Concept, then we go for manufacturing, then we go for testing of the part, then real world testing we do of the part, then results, and if the results are not as per our standards, we again go to the design phase. So it's a very time consuming task. It takes a lot of time and money is invested in this. So to overcome, this problem, reverse engineering can play a significant role. How? From the concept itself, we can go for simulation of the process. Instead of manufacturing, we can simulate the process. We can optimize the design. Then we can identify, analyze the results. And then we go for design loop. We again go for design loop before manufacturing. So we are no longer spending any amount in manufacturing. Manufacturing cost is very high. And then we go for manufacturing. So the chances of failure of a product is very, very, very much. So convention, many cost and expensive design loops are there. In fact, in rapid prototyping or reverse engineering method, the design loops exist even before manufacturing is happened. Okay, so it results in cost saving as well as time savings. So basically, I'll showcase this with the help of this slide. What is the generic process of reverse engineering? It initiates with scanning of a product. If the product is in front of me, I will scan it. Like I will scan my whole body. Okay, it is possible. There are startups, in India who do reverse engineering for, artifacts also. So I can reverse engineer, I can scan my body, and then I can develop the point cloud data using the reverse, 3D scanning or whatever way of methodology I can use. So I can develop point cloud data. I can process that point cloud data. The data can be in the point cloud form or it can be in the form of scans. We all have seen X-rays in our life, X-ray images. So that X-rays image is nothing but it's a single. In reverse engineering, we have multiple number of those X-rays. Stitch them together. Model is developed using a number of algorithms. So a computer science engineer is required here. So triangulation problem, we use triangulation to develop our STL model, develop CAD-based surfaces like B-spline curves or non-uniform B-spline curves, or we can go for direct 3D printing, as well as we can use these for inspection also. So this is the basic generic flow cycle of a reverse engineering process. These are some of the technology. So the most popular one is laser-based reverse 3D scanning, computer CMM machines. Then we have computed tomography machines, CT scan machines, MRI machines. So these are some popular machines in reverse engineering field. If somebody wishes to get the details of these, they can always contact me. Okay. Now let us understand the prospect of this technology. This is about the basics of what reverse engineering is, what it can do for us, what people are doing all over the world. Let's see that and understand the importance of this technology using some case studies. So this is the first case study which showcased the prospects of reverse engineering in automated component repair. And this happens in almost all the engineering field. There is a component failure which occurs. Okay. So here you can see there's a component failure. So component failure, there is a damage to a failure. We go for reverse engineering of this component. We have developed the point cloud data, which is shown at the bottom right. And then we can use additive manufacturing techniques. So this technology is a hybrid reverse engineering and additive manufacturing machine which was developed. And then we can directly print the metal part on the same component failed. What we do currently, we replace that component. No, we cannot replace it. It's very costly. What we can do, we can repair it. In the same part, we can do the repair. And we can utilize that component for our engineering use. Again, to see a repair, this is a case study of repair of a compressor blade. So here there is a compressor turbine blade which encountered some damage or wear and tear. So you can see some wear and tear in the component compressor blade. So we do reverse engineering. We develop the point cloud data. We process that point cloud data. You can see the damage model is shown here. So some part is missing. Again, we replace this turbine or we do welding and lot of stuff. We spend lot of time in this. Our machine, time is spent, our machine remains still for a large number of days because of this. What we can do, go for reverse engineering. We can develop tool paths for this, and then we can go for direct 3D printing, metal-based 3D printing. Look, we have prepared the same component by 3D printing. Metal-based 3D printing technique, basically direct energy deposition technique has been used here. And we can finish it, we can use the same component for further use. So it will save the time as well as cost. Again, replacement of a failed part. So this is a gasket which has been failed in some engineering operation. So we go for replacement of these gaskets. These small components cost us lot of money and time. Again, I am repeating. Okay, so what we can do, we can again reverse engineering this, gasket. Now some of the part of this gasket is missing, completely missing. So what we can do, we can extrapolate the design. We can extrapolate the existing design to develop the complete CAD model. And this CAD model can be printed or it can be machined using CNC machines by development of the tool parts, and we can have a gasket with us and we can use this gasket for engineering application. Again, replacement of failed part. This is a gear which failed during some engineering operation. This is the process of reverse engineering. Point cloud generation, mesh generation, solid model development, and 3D printed part, the gear that engineered. Finally, we have used this 3D printed gear which we have obtained using reverse engineering model in an engineering application. This all is what people believe that reverse engineering helped them, like repair. No, it can do a lot more than this. What it can do? It can develop a customized product for us also. How it can develop a customized product? This is a case study where a helmet has to be designed based on the structure of the human body, okay? Customized helmet, which will fit exactly to the size of the human head, okay? So reverse engineering, you can see the steps are involved, okay? The point and all those things. So curvature has been modeled using reverse engineering. And then in the curvature, we will use CAD model development software to develop a design of a helmet. And this helmet has been fabricated. This is a customized helmet, and you can do the improvement, you can add accessories to it, you can add cameras and all those things into it. Okay? So this is reverse engineering for a customized part development or a new product development. Again, for new product development, this is an example of a orthosis. Okay? In biomedical industry, reverse engineering is used a lot now. For implants, for orthosis, for prosthetics, it's used a lot. So this is one of the examples for that, because our right hand teeth design is completely different from the center teeth design, and whole body design of one human is completely different from another human. So reverse engineering can play a significant role there. Okay. Again, this is a customized implant study. This is a study which has been carried out by me only with the collaboration of AIMS New Delhi. There is a patient who encountered an accident in the skull. Currently what we do, we fix the plate. The plate size are standard, and we put whole high weight plate on the top of the human skull. It creates a lot of problem. So what we can do instead, we can develop a customized design. Whatever the cavity is, jitna cavity ka bhag hai, bas usi ko hi aap model kare, and it will be tight fit in cavity. Okay, it will. So this type of implant will not require any screws. One screw costs us 10, 15, 20,000, depends on the material that we use. If we are going to use titanium implants, it will cost us a lot. So this is one of the solutions for reverse engineering for development of a customized models. Okay, so you can imagine, this is biomedical study, but you can always implement it for your own applications. Okay, therefore I have put in these case studies. And then it can also be used for morphological characterization, like components which are very difficult to characterize. For example, casting product. There are a lot of defects in casting products. Okay, so automobile industry, they use reverse engineering to identify the porosity, to identify the micro cracks, okay, using reverse engineering. So this is again a metal foam component which is considered to be very complex shape, and ask you to get me the volume of this fabricated sample. It is very difficult to obtain the actual volume. We can always say this is the ideal volume, but actual volume if I want, I cannot get from any characterization method. But using reverse engineering, using such methods, like this is metal component, then metal CT scan image, X-ray image, and then the model, and this is the reconstructed model. So using this reconstructed model, we can get the porosity in the component, we can identify the volume of the component, the surface area of the component, actual size. In fact, we can use this CAD model for finite element analysis directly. So it will give much more reliable results as compared to the ideal CAD models that we develop for FEM. Generally what we do develop the ideal CAD models. So they will give results, but that will not close to the reality. But if we are using the reverse engineering CAD model, they can give us ideal results. So what are the opportunities and what are the challenges in this? Okay, some challenges in various engineering fields. So first of the challenges, very higher lead time for parts, then requirements of of inventories and all those things, high downtime due to difficulties in procurement of these spare parts and all those things. Machine remains idle for 10, 15 or months. Okay, and those machines are very cost expensive. Then there are very difficulty in the improvement of the existing designs or existing machinery. We are using old machines and their efficacy is very low. So how we can improve it? These are the challenges. And then there is a huge amount of lack of skill set in reverse engineering field currently in India. So what are the solution? Development of digital inventory. This is one word which is very powerful, and I will very much sure that this will change the scenario of engineering field in the coming future. Instead of maintaining the whole physical inventory, we can have a digital inventory of our parts. Instead of having 500 or 1000 crores of physical inventory, we are having only CAD models of our parts. And those CAD models, on demand, we can print it or we can fabricate it. So we are no longer handling large amount of inventories. Okay, so this is the requirement of digital inventory and technology to provide spare parts on demand, like 3D printing, additive manufacturing, or 5 CNC machines or 10 axis CNC machines, large scale machines. Then ability to achieve custom modification, as I've showcased you, custom part modification can be achieved. Okay. Then development of high-end systematic reverse engineering solution with integration with additive manufacturing techniques. Okay, so it will give us high amount of we can achieve those challenges easily if we are having systematic integrated product development process using reverse engineering and 3D printing. And then we want training programs so that our engineers, they get trained in this field. So technologies which are commonly used to achieve these the challenges to 3D scanning machines, CMM machines, CT scan MRI machine, additive manufacturing systems, CNC machine systems, and softwares and algorithms. Okay, there are the software like Mimics, Polyworks, which works perfectly for these types of techniques. Now let us think what are the business opportunities in this area. Okay, the business opportunity which lies is we want a center for reverse engineering, at least in India. At least the location such as this Singrauli, it will help with different industries a lot. And what this center can do for us, it can give us a digital inventory. Okay, it can not only give us digital inventory, but it can also provide support to the local vendors also. Okay, so digital inventory it will provides. Then training, as I told you, local vendor training, their certification. We train the small industries in the area of reverse engineering. We can provide the facilities for these reverse engineering, the local vendors. Advanced designing, we can develop complex shapes. We can improve the design also. Then research and development. This is very important because reverse engineering area still is in development phase. So R&D becomes very important in this area. And R&D can be specific to an application also, or it can be general also. Then rapid manufacturing of a product. Like I've told you, integration of reverse engineering with additive manufacturing or CNC technologies can result in rapid manufacturing of a product. So we can provide spare parts on demand. Okay. And then certification and testing. This is what we are lacking with. We don't have enough certification standards or testing standards for reverse engineered products. So we need to establish a center which can provide such things. So coming to IIT BHU point, we are having metal 3D printer, we are having polymer 3D printer with us, we are having some 3D scanner with us also. So we can provide some solution in that regard, being a knowledge partner with NCL. So you can always reach us in development of such systems. Also we can handle some projects also so that you get an idea of how this technology can help you. Okay, thank you.
Thank you, sir, for your valuable insight. I request GMDIC Shri A.K. Mansoori, sir, to felicitate our guest with a memento.